Synthetic division. Oh, the joys of being a mathematician. Mathematicians like to make things that are very, very complicated simple. In other words, they like to find shortcuts. And synthetic division is a shortcut to long division. Say we're given a polynomial 2x to the fourth minus 15x squared minus 10x plus 5 divided by x minus 3. What we know now to do is use long division, where we have this polynomial, the dividend, and then we have the divisor right here. And we're looking for what multiplies by x to give us 2x to the fourth. And then we'll do that same thing to the negative 3. Put it all together, subtract those things, working our way down until we have some remainder. In this case, it was a remainder of 2, so that 2 is still needing to be divided by the x minus 3. That's what we know of right now. But synthetic division is the shortcut to that. Look at all this work on the left, and that same process is simplified right here with synthetic division. Looks a lot nicer, doesn't it? So that's what we're going to learn today, is synthetic division. And just a few pros and cons to talk about. First off, when you're looking at long division, you can divide any polynomial by another. Notice that this has a degree 1, the divisor does. If we had a polynomial of degree 2 or 3, we could do that with long division as well. However, it's just going to be a slower process overall because we have to do so much writing. Synthetic division, on the other hand, it's a lot faster, so that's a plus side. It looks a lot nicer, sleeker, but you only can divide by polynomials of degree 1. So notice that this is a polynomial of degree 1. That's the only types we can use synthetic division with. That makes it really slick and easy. So that's a downside to synthetic division. But let's go ahead and try it right now. Alright, so we're going to synthetically divide 2x to the fourth minus 15x squared minus 10x plus 5 by x minus 3. So this was the problem that was on the front of this paper. So how do we synthetically divide? First, we want to just write down what numbers were in our polynomial. In other words, what coefficients we had. So starting with the leading coefficient of 2, that went to the x to the fourth. The x to the third, it's not present in our polynomial. We skip to x squared. So just like long division, we're going to put in 0 as a placeholder for that. And then comes x squared, that coefficient is negative 15. The x term is 10, and then we have 5 for our number value. So you have it set up like this. I leave a space where I'm going to write numbers right here, and I just draw a line. Next, we need to figure out what we're going to be dividing by. With long division, you're taking this whole thing right here. But with synthetic division, you're going to solve for x. So x minus 3 equals 0. X is going to be 3. Since x is 3, we're going to put that right on the outside of this bar. Now, to synthetically divide, the very first step after you have this set up is to drop down your first term, the 2. Just comes right on down. After that, it's just multiply and add, multiply and add. So we're going to multiply the 3 by this 2 we dropped down to be 6, and we're going to put it right underneath the next coefficient. We're going to add these two together, so 0 plus 6 is 6. And now I'm going to do the same thing. 3 times 6 is 18. 18 then goes under the 15. Negative 15 plus 18 is 3. Now 3 times 3 is 9, which is going to go underneath the negative 10. Add those together, you have negative 1. 3 times negative 1 is negative 3. 5 plus negative 3 is 2. So this is your answer. But we have to remember the last term, that's our remainder. Just like we had one out in long division, our very last term is a remainder with synthetic division as well. Now this doesn't look like a nice pretty answer that we had on the front side with long division. That's because we have to put in those x terms because we took them out when we synthetically divided. Now, when we're dividing by, say, x minus 3, we're taking an x out of each one of these terms. So each one of these terms is going to be 1 power less than what it started with. So this x to the 4th, the first term in our quotient, our result, right down here, is going to be an x to the 3rd, 1 less than this power. So we're going to take this 2 as the leading coefficient, and we're going to put an x to the 3rd right there, 1 less than the power we started with. Now we're going to add 6, and we just keep on going down the line now. Since we had x to the 3rd, we're going to write x squared, plus 3 comes down, 1 less than x squared is x, minus 1, and then we have this plus the remainder, 2, divided by x minus 3, because that's what we were really dividing by. So this right here is your answer. And that's the same thing we had on the front side. Okay? If you think you have the process, go ahead and try this one on your own. But right now, I'm going to, oh my gosh, I'm losing light. Can we see this okay? Oh, I don't know. It might be bad. We're gonna go like this. Okay, hopefully you can see that I'm running out of daylight. Okay, so again, when we have synthetic division, we're going to set it up with the leading coefficients. So we're going to do a little box. We're going to write down the leading coefficient of the x to the 3rd, which is 1, the 5 for the x squared, the 5 for the x, and the negative 2 for the number value. Now we have to find out what x equals. So we're going to set this up so x plus 2 equals 0, so x equals negative 2. That's what we're going to put outside right here. Remember, our first step is to drop down this term, the 1, and now we can do our multiply and put it in space. So multiply negative 2 by 1 is negative 2. Oops. Multiply 1 is negative 2, goes right there. 5 plus negative 2 is 3. Negative 2 times 3 is negative 6. 5 plus negative 6 is negative 1. Negative 2 times negative 1 is positive 2. And negative 2 plus 2 is 0. Remember, this last one is our remainder. And this is our leading coefficient. And the x is 1 power less than what we started with. We started with an x cubed, so now we're left with an x squared. Minus 3x minus 1 plus, we have no remainder. There's nothing left. So if you wanted to, you could write plus 0 over x plus 2, but in the end that's just 0, so our final answer is this. X squared minus 3x plus 1. Notice some differences between this and long division. In long division, we're actually subtracting what our values are, but here we're always adding. We're always adding these two values together because we've already kind of taken the opposite right here when we solved for x. So be aware of that. Long division, you're subtracting. Synthetic division, you're adding. And who doesn't like addition? When given the choice between addition and subtraction, I would take addition any day. Okay, my daylight just went away, so I have to make sure this still looks okay. All right, it does. The last thing we're going to do is determine if this polynomial, 2x to the 4th plus 5x to the 3rd minus 8x squared minus 17x minus 6, we're going to see if it has a factor of x minus 1 or a factor of x minus 2. So if we look kind of back at factors, I'm going to erase this. Say we had 201 divided by 8. We want to see if 8 is a factor of 201. So if we're going to divide that using long division, we're going to see what multiplies to get 8 close to 20. Well, 2 times 8 is 16, which gives us 4 left over. Bring down the 1, we have 41. What gets 8 close to 41? Which that would be 5. But 8 times 5 is 40, so we have a remainder of 1. 8 is not a factor of 201 because it has that remainder. If we did 200, that would make this a 0, our remainder would be 0, and hey, 8 would be a factor of 200. So we're looking for a remainder of 0 when we're doing this. So we want to set it up so we have two synthetic division problems. One where we have 1 out in front for that x minus 1, and another where we have 2 out in front for this x minus 2. So we're going to take the coefficients 2, 5, negative 8, negative 17, and negative 6. 2, 5, negative 8, negative 17, and negative 6. And we're going to do our synthetic division. Bring down the 2. 1 times 2 is 2. 5 plus 2 is 7. 1 times 7 is 7. Negative 8 plus 7 is negative 1. Negative 1 times, 1 times negative 1 is negative 1, which is, and then negative 17 plus negative 1 is negative 18. And 1 times negative 18 is negative 18. Add those two numbers together and you get 24. Right there's a remainder, the 24. We know that's not going to work. So that one is not a factor of this polynomial. Let's try the x minus 2. So bring down our 2. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. Oops, excuse me, positive 18. All right. Negative 8 plus 18 is 10. 2 times 10 is 20. Negative 17 negative 17 plus 20 is 3. 2 times 3 is 6. Negative 6 plus 6 is 0. Here's our remainder. Remainder of 0 means we have a factor. So x minus 2 is our factor of this polynomial. So there's our factor. Okay? So highlights, synthetic division, faster way for long division. Long division, you can do any degree polynomial. Synthetic division, you only can divide by polynomials of degree 1. Other things with synthetic division, you're adding. These are all addition. Long division, you're subtracting. So take your pick in that sense. But that's synthetic division. And if I ask you in class what went wrong with this video, it's probably the sunlight that's fading on me. So otherwise, I'll see you in class.